The second cause for the bonding was given by Lewis as Lewis concept. Now before understanding this concept, I would like to introduce you with the noble gases or inert gases which belong to the 0 group or the 18th group of the modern periodic table. In the 18th group of periodic table, or as I called it as 0 group, we have got helium, neon, argon, krypton, xenon and radon. Here helium has an atomic number of 2, neon 10, argon 18, krypton 36, xenon 54 and radon 96. Now these elements are the part of 18 or 0 group of the periodic table. Now let's observe their valence shell electronic configuration. For that we can refer to the method of electronic configuration in the chapter atomic structure. Now helium has a configuration of 1s2, neon has a configuration, valence shell configuration as 2s2 2p6, argon 3s2 3p6, krypton 4s2 4p6, xenon 5s2 5p6 and radon 6s2 6p6. Now dear student, with an exception of helium, if we observe the valence shell configuration of neon, argon, krypton, xenon and radon, we can conclude that their valence shell configuration is ns2 np6, where n represents the valence shell of an atom. In case of neon we have got 2s2 2p6 in the valence shell. In case of argon we have got 3s2 3p6 in the valence shell. In case of krypton we have got 4s2 4p6. In xenon it is 5s2 5p6 and in radon it is 6s2 6p6. So in general the conclusion is that in case of inert gases, that is 0 group or 18th group element, we will have the general electronic configuration of the valence shell as ns2 np6, where n represents the valence shell. Now the question is why we call these elements as inert gas. Reason is that these elements possess a stable configuration and hence low potential energy and hence more stability. That means they do not undergo chemical reaction, they are less reactive, and this is the reason why we call them as inert gas. So now moving ahead, we can say that if an atom or element attains noble gas configuration, that is ns2 np6 configuration, then we can say that those elements will get stabilized. So let us consider an example where we shall be talking about NaCl molecule in which sodium and chlorine have been bonded to each other. Now let's check out that NaCl is a molecule in which sodium and chlorine atoms are bonded to each other by the loss and gain of electron, which we will discuss further just for the sake of understanding that how or what kind of configuration an atom can attain after bonding, that we are looking here. Else more details will be found in the later part of the chapter. So here sodium has an atomic number of 11, chlorine has an atomic number of 17. Now sodium will undergo the loss of one electron forming Na plus, and Cl will gain one electron forming Cl negative. Now if we observe the initial configuration of sodium, it is 1s2 2s2 2p6 and 3s1, where that of chlorine is 1s2 2s2 2p6 3s2 3p5. Here in the valence shell of sodium we have got 3s1, whereas we have 3s2 3p5 configuration of chlorine. Now when sodium will undergo the loss of one electron, it's obvious that electronic loss will take place from the valence shell. So its new configuration will be 1s2 2s2 2p6, while in case of chlorine, after gaining one electron from sodium, its configuration will be 1s2 2s2 2p6 3s2 3p6. Initially it was 5, now one electron has been added, so it will be 3p6. So if we observe the valence shell configuration of sodium and chlorine, it is resembling to ns2 np6 configuration in both the cases. So now we can conclude that during bonding, species attain inert gas configuration and hence get stabilized.